Chapter number 9, problem number 14, line balancing. In this case, we have 6 workstations or tasks that have to be assigned to certain workstations. We are given tasks A through F, and we're giving how long it takes to complete a task at a particular workstation. And we're also given the predecessors. So you have to complete, for example, you have to complete A before you can do B. Before you can do E, before you can do task E, you have to complete B and C. So we need to replicate what's in your textbook, and you can again use the copy and paste feature. So you go to chapter 9. The only one we're going to use is assembly line balancing. There are 6 activities, A through F, and we'll just leave them labeled as A, B, C because that's what they're labeled in the book. So we will use my pre-populated sheet. I'll just copy and paste this to save us a bit of time. One thing with entering the listing for A, B, C is when you have just A, it doesn't matter if it's capitalized or lowercase, that's fine. But it is important to, you can see for activity E, it's B comma C. The comma is actually quite important. If you go BC, it'll think it's activity or task, in this case, BC, which is not. It's activity B, then comma C. I had a student one time who was getting the wrong answers because they're going BC. No, B comma C. D comma E for F. That's the way the software knows that it's 2 different activities. All right. So one of the things we have to do is we need to determine the cycle time. Now you take the cycle time is the time available divided by the output in this particular case. So you could do this separately if you want, but the time available is a 40-hour week, 60 minutes per hour, and the information is given in seconds. So we need to multiply it by 60 to convert that to seconds. We take it by the weekly demand of 4,800 units, and we get a cycle time of 30. What that means is the maximum amount of time we can assign to any one workstation is 30 minutes. Now, you also need to, for the purposes of this course, always change the priority rule to priority rule number 2. And you can see the priority rules over here on the under column G through K. We're always going to use most following tasks, which is priority rule number 2. So when you go to do your quizzes and your final exam or midterm, then that's the priority rule that you need to use. Now, we have several things to answer. In part A, it says draw a precedence diagram. Now, when you go to do this, you'll be given a choice. You're not going to have to actually draw it. So to answer part A, if you just, so to do part A, this is what it's going to look like. And there is, if you, by the way, if you check the solution manual, it has a prettier diagram than what I'm going to do. You look at station number 1. The only activity assigned is A. So station 1, activity A. Workstation 2, the only activity is, or task is B. But you see that C and D are combined. So workstation 3 has C and D. So workstation 3 will do task C and task D. And if you see, the time totals up to be 30 seconds, which is the maximum you can have. Workstation number 4 only has activity E. So workstation number 4 has activity E and only E. And workstation number 5 has F and only F. So we're able to reduce the number of workstations from 6 to 5, which improves our efficiency. Now, in this particular case, so that's how you answer part number 1. What is the cycle time? Well, here's our answer right here. Our cycle time is 30 seconds. The cycle time is either the time available divided by the output, or if we didn't have that information, it would be the longest task time, which is also 30 seconds. So in this case, the two match. The theoretical minimum number of workstations is given to, like if every workstation had exactly 30 seconds assigned to it, and it doesn't. So we have waste, which is called idle time. So the answer for part C is here, which is 4. In a perfect world, we'd like to have 4 workstations, but we don't. We actually have 5, which is the answer that we came up with. And you can't get 4 just based on the order that jobs needs to be done and the task times. Assign tasks to workstations. Already did that in part A, but just to reiterate, station 1 has activity A, station 2 is B, station 3 is C and D, station 4 is E, station 5 is F. How much idle time? Now, for each cycle, it gives you the answer here. 30 seconds of idle time per workstation. And what that is 10 seconds of idle time for workstation 1, 20 seconds of idle time for workstation 4, for a total of 30. So that's how you get the 30. 10 seconds of idle time at 1, 20 seconds at 4 for a total of 30 seconds of idle time. Every single cycle will have 30 seconds of waste. Now, in part F, sorry, that was part E. My apologies. All right. Now, in part F, what is the overall efficiency? Well, in F, it's 80% when you have 5 workstations. And you can simply change the 5 to a 6, and you'll get the calculation for what is the efficiency with 6 workstations. And the efficiency will not be the same. I'll let you try it out to see whether it gets better or worse. But you should know the answer in the sense that if you have 80% efficiency with 5 workstations and you add more workstations and still produce the same amount of work, it should be fairly obvious that what happens to your efficiency, but I'll let you see what happens to the number. So that's 914. My apology for earlier having the D answer is actually E. All right. Thank you.